Hello class, and welcome to a tutorial on using Microsoft Excel's Solver. We're going to do this in two parts so the video file doesn't get huge. This is going to be part one, and in this tutorial I'm going to just help you get set up for using Solver. By that I mean we're going to set up the spreadsheet so that using Solver will be pretty easy. In order to know how to use Solver, you need to know how to set up a linear programming problem. A linear programming problem is a particular type of decision faced by a decision maker that involves multiple decision variables. Said differently, there's different subsets to the decision. So I'm going to give you a simple example. We're going to set up the spreadsheet so that Solver can find an optimal solution for us, and then in part two we're going to use Solver to find that perfect solution. So in this example I'm coming up with, let's say we're going to produce and sell shoes. And let's say we produce both athletic shoes and we produce dress shoes. So our decision is, how many of each should we produce? How many athletic shoes should we produce? How many pairs of dress shoes should we produce? And we make a certain amount of money on each type of shoe. And let's say we make $10 on athletic shoes and $15 on our dress shoes, and then we want to maximize our profit. Obviously we want to make as much money as we can, so we want to do that, but there's some things that are keeping us from making as much money as we might like to, and those things are called constraints. I only have so much labor, I only have so much demand, I only have so much material. So these are examples of constraints. So a linear programming problem will have three things. Number one, decision variables. Number two, an objective function. And number three, constraints. Well, Microsoft Excel doesn't know what a decision variable is, but it does know what a cell is. So I'm going to have particular cells, for example D1 and D2, serve as decision variables, okay, or represent our decision variables. So right here I'm going to put some labels. I'm going to put the label A here and the label D here, and we're going to let A represent the number of athletic shoes that we produce, and I'm actually going to have that number go in cell D1. So again, in cell C1, that's just a label. The letter D there is to remind me that in cell D2, that's the number of dress shoes to produce. So these cells right here, D1 and D2, I'm calling those my decision variables. I'm going to format those cells and make them a color to remind us that my decision variables are those yellow cells right there. So now if I put a 10 there and a 15, what I'm telling you is I'm going to produce 10 pairs of athletic shoes and 15 pairs of dress shoes. I'm going to delete those values because in a little bit, in part two, we're going to ask Microsoft Excel to put the values in there for us. In other words, to find out what is the best product mix for us. Okay. The next thing I need is something called an objective function. An objective function is a function of your decision variables that tells us what our objective will be. In this case, our profit. What will our profit be if I produce a certain number of athletic shoes and a certain number of dress shoes in this scenario? So in this case, I'll make $10 for every pair of athletic shoes I produce, and I know I'll make $15 for every pair of dress shoes I produce. So I can write an objective function here that says that my profit equals 10 times D1 plus 15 times D2. So if we look at that formula, 10 times D1 is the amount of money I'll make from my athletic shoes, and 15 times D2 is the amount of money I'll make from my dress shoes, and you add them together and I get my total profit. So now whenever I put numbers in here, the profit is automatically computed. Okay? So in a little bit I'm going to ask Microsoft Excel's Solver to manipulate D1 and D2 to find numbers for D1 and D2 that make the value in cell D4 as big as possible. Said differently, I want it to tell me what to produce to maximize my profits. Now again, I don't have unlimited profits. I don't have unlimited potential. I have some things constraining me. One of the things constraining me is I only have so much labor. Let's say I have 6 employees and in any given week I only have 240 hours of labor available. So I'm going to put 240 here representing my labor. So this will be my labor constraint. Now in cell C7 I want a formula that computes the amount of labor I use for a given product mix. Well, I know that for every pair of athletic shoes I need a half hour of labor, and for every pair of dress shoes I need a full hour of labor. So I can add a little formula here, equals 0.5 times D1 plus 1 times D2. And look at that formula and make sure you understand it. But 0.5 times D1, a half hour times the number of athletic shoes I produce, that's the amount of labor used for athletic shoes. 1 times D2, that's the amount of labor used for dress shoes. Add them together, that's the total amount of labor I use. Well, in a minute I'm going to tell Solver that this cell's value has to be less than this number here. So I'm setting things up right now in such a way that in part 2 it'll be real easy to use Solver to solve these problems. Okay, the next constraint I have is materials. Let's say I only have 100 yards of materials to use, so that I can't make more shoes without materials. So in cell C8 I want to put a formula that computes the amount of materials I use for a given product mix. So I know that it takes 0.2 yards of material to make a pair of athletic shoes. So 0.2 times D1 is the amount of material I'll use when I make my athletic shoes. I'm going to add to that the amount of material I'll use when I make dress shoes, and that'll give me the total material. So in this case I know that it takes 3/10 of a yard of material to make a pair of dress shoes. Okay, so in cell C8 I've put a simple formula that computes the amount of materials I'm going to use for any given product mix. Okay, also have a couple of other constraints. One constraint says I have to produce at least 75 pairs of athletic shoes, because I've already committed to do so. So we might call this an order, because someone's ordered 75 pairs. So the number of athletic shoes has to be greater than or equal to 75. Well, a real simple formula for the number of athletic shoes just equals D1, because that's where that value is going to wind up. Finally, I can't sell more than 200 pairs of dress shoes. So the number of dress shoes is in cell D2, and that's a demand constraint. I can't sell more than that because more than that are not demanded. Okay, so I've really set things up well for me to now use Solver. I've got decision variables that Excel can tell me what these numbers should be. I've got an objective function that says here's what happens when these numbers are what they are. And finally I've set it up to where I can say this number has to be less than this number, this has to be less than this has to be more than this has to be less than this, and I can let Excel tell me what the best course of action is. Okay, we'll stop there. We'll pick it up in part 2.